chaps, we are continuing function, and we're going to look at hyperbolas today, revisiting hyperbolas. Not a difficult one, just learn one or two new things. So I'm starting with a simple, like your basic hyperbola. Let's say that's going to be f of x equal 3 over x. Okay? So let's remind ourselves, what are the asymptotes? Okay, the asymptotes are these vertical and horizontal lines that the graph always get closer and closer, but they never reach. Let's start with a vertical. What is the, well, let's start with horizontal. That's easier. What's the horizontal asymptote in this case? Okay, y equals 0. That's the horizontal. Okay, that one. Vertical, x equals 0. The x equals 0 is sometimes difficult to remember how to call it. Okay, the y-axis, so x equals 0. Now, line of symmetry. Okay, we mentioned our word symmetry, and we talked about the line of symmetry last lesson with parabola. Also, hyperbolas have a line of symmetry. Can you think of where these line of symmetries are? No, don't worry the name, but where? Draw for me with your hand. Okay? Not really. If you take this as the line of symmetry, that means if you fold that, you should get the same, but you're not. Okay? Right, look at this. If you fold that, then that's going to go over here, but that we don't have anything there. So Georgia is drawing it very nicely. She's saying, oh, there's a line of symmetry here. If I fold it this way, I'm going to just overlap where that function is, right? But there's one more. Yes, yes, okay? So there's another one here. If I fold the paper this way again, I'm going to overlap there is a symmetry, okay? Symmetry means, okay, along this line, it's symmetrical. Also along this line, it's symmetrical. Okay, as if I put a mirror here, mirrors each other. Same here. Okay? So what is the line of symmetries? What will this line be called? Okay? What's the angle here? 45 degrees, isn't it? Okay, when that line is 45 degrees, okay, that line is y equal x. Okay? Because when x is 0, y is 0. When x is 1, y will be 1. When x is 2, y will be 2. So that's the line y equal x. We okay with that, guy? Okay. What will this line be? Minus. So y equal to? Minus x. Where x is 1, y is minus 1. When x is 2, y is minus 2. When x is minus 3, y is equal 3. It's always y equal minus 6. Okay? Please write that down. Okay, I'll pause here. Very, very important. So this is new stuff. Lines of symmetries of hyperbola. We'll start with that, and then we're going to do some vertical shifts. Right. So now we're going to do the same thing, but I've kind of massaged this function. So it's minus 3 over x plus 2. So the minus 3 over x flips everything, right? Whenever I put a minus, we're doing a reflection over the x-axis. So if before it was like that and that, now this is going to be up and this is going to be down. But that plus 2 also, I'm sure you understand, it's a vertical shift. Okay, so sometimes with these parabolas, it's actually worthwhile drawing the asymptote before drawing the function. Okay? The vertical asymptote will be the same, but what will be the horizontal asymptote now? And y equal 2. And it is really worthwhile drawing it first. Here, so that's, let's say, it's 2. Now, if it wasn't for that minus, I would just draw the same thing. But that minus flips everything. So this would used to be like that, now it's going to be like this. And this that used to be like that is going to be like that. Okay? So we've got the asymptotes right. What about the line of symmetry? Good, good. So now the line of symmetry, we'll draw them like this. Okay? It's always going to be x and minus x, but now we've got vertical shift. They both went up. So it's going to be x plus 2 and minus x plus 2. Okay, guys? The number in front of x is always going to be 1 or minus 1. The only change that we have here is that we have some kind of vertical shift. Okay? So again, make a note of that, and we'll move on to the next bit. Right, so to finish up this lesson, let's look at an example that will Example. So I draw a graph, and we need to figure out the name of that function. In other words, to find a and x. Okay? So let's, and I know that there is a certain asymptote y equal minus 3. What is q then? Q is minus 3, isn't it? Okay? So q always tell you the horizontal asymptote. Now let's also write down what are the asymptotes, just like we did in the last one. Okay? The asymptotes are, one is given for us, that's y equal minus 3, that's a horizontal. What's your vertical one? X equals 0, okay? In grade 10, when we didn't have horizontal shift, the x equals 0 is always a vertical asymptote. Okay? Now, so we still need to figure out a. Okay, I'll just leave it for a second. Let's talk about lines of symmetry. What are the lines of symmetry? It's worthwhile drawing them, okay? So one is going to be like this, and the other one will be like that. Y equal to x minus 3. So this is going to be y equal x, and we shifted it down minus 3. And the other one? Minus x minus 3. So it's always starting y equal x or y equal minus x. Okay? And then we are just doing shift, which in this case was minus 3. Okay? Right, so we've got all the line of symmetries, all the asymptotes. The last thing that we need to get is a. Before we actually get it, is a positive or negative? It's negative because, see, I realize that's been flipped. Normally, the usual one, when a is positive, we've got this one here and this one there. But we can see that it's flipped, that means a is negative. How do we find it? Substitute. Which point? 3 minus 4. Yeah, I think anyone's pretty much getting it. Where the mistakes would come is where you forget which one is which. Okay? So your first number is always the x, the second number is always the y. So if I put, okay, instead of f of x, I'll put minus 4. Instead of x, I'm going to put 3. Okay? So I substitute 3, okay, and minus 4. Move the 3 over to this side, so I'll get a over 3 equal minus 1, a equal minus 3. And indeed it was negative. So final answer. Instead of a, I'm going to write minus 3. And that's the answer. Okay? Right, I'll just pause here, let's do the exercise in the book, and I'll see you guys tomorrow.